On July 14, 2015, a spacecraft the size of a grand piano flew past a small frozen world at the edge of the solar system, moving at over 30,000 miles an hour, close enough to see individual mountains rise off its surface. And it did all of that after a journey that had taken 9.5 years to complete. It had one shot. No second pass, no breaking into orbit, no chance to slow down and take a closer look if something surprised the science team. Just a single, high-speed flyby, over in a matter of hours, to answer a question humanity had been asking since 1930. What does Pluto actually look like up close? And what came back completely broke the picture scientists had been carrying in their heads for decades. Because the small, dead, frozen ball of rock everyone expected to find turned out to be something else entirely. A living, changing, geologically active world that, by every reasonable model that existed before 2015, should not have been possible at all. The mission is called New Horizons, and its story starts long before that flyby. It launched on January 19, 2006, from Cape Canaveral, on a trajectory built for speed above almost everything else, because Pluto was so far away that every extra bit of velocity mattered. The spacecraft left Earth faster than any human-made object ever had before it, and even at that blistering pace, it still took over 9 years just to reach its target, using a gravity assist from Jupiter along. The way in 2007 to bend its path and pick up even more speed for the second half of the journey. For most of that 9.5-year trip, New Horizons wasn't even fully awake. To conserve power and reduce wear on its systems across such an enormous span of time, the spacecraft spent long stretches of the journey in a kind of electronic hibernation, checking in with mission control just once a week to confirm it was still healthy, before finally waking up fully as it approached its target. And here's what makes the flyby itself so nerve-wracking in hindsight. Pluto is so far from Earth that even communicating with the spacecraft involves a signal delay of more than 4 hours each way. That means during the actual flyby, as New Horizons sped past Pluto at a distance of just under 8,000 miles, roughly the same as flying from New York to Bangkok. On gathering images and data on a scientific target humanity had never seen up close before, mission control on Earth had no way to watch it happen in real time. There was no live video feed, no moment-by-moment updates. The spacecraft executed its entire meticulously planned sequence of observations completely on its own, in total silence as far as Earth was concerned, and only afterward, when it turned its antenna back toward home and began transmitting, would anyone know whether it had actually worked. It worked. And what came back rewrote the textbook entry on Pluto almost immediately. The first thing that caught everyone's attention, immediately, visually, unmistakably, was a massive, pale, heart-shaped region, stretched across a huge portion of Pluto's surface, later named Tombaugh Regio, in honor of Clyde Tombaugh, the astronomer who first discovered Pluto back in 1930. But the heart shape wasn't just a striking visual coincidence. The left lobe of that heart turned out to be something scientists hadn't expected to find anywhere on Pluto at all. An enormous basin of nitrogen, methane, and carbon monoxide ice, roughly 620 miles across, now called Sputnik Planitia. And it wasn't just sitting there, frozen and static. It was actively convecting, meaning the ice itself was slowly churning and flowing, driven by heat rising from below, in patterns that resembled the surface of a slowly boiling pot, broken into huge polygonal cells, each one many miles wide, constantly, if slowly, renewing itself. That single discovery alone forced an enormous shift in how scientists understood Pluto. A small, cold world sitting billions of miles from the sun, with no obvious source of internal heat comparable to Earth's molten core, simply wasn't supposed to have active, churning ice on its surface at all. Before New Horizons arrived, the reasonable expectation was a world locked in geological silence, its surface unchanged for billions of years, covered in craters slowly accumulated since the early solar system. Instead, large sections of Pluto's surface showed almost no impact craters whatsoever, a telltale sign in planetary science that a surface is geologically young, resurfaced recently enough that the slow, steady rain of small impacts hasn't had time to leave its usual mark. Some regions of Pluto, according to the crater counts New Horizons allowed scientists to calculate, appeared to be no more than about 10 million years old, a blink of an eye compared to the 4.5 billion year age of the solar system itself. Something on Pluto was still actively reshaping its own surface, and nobody had a complete explanation ready for how a world that small, that cold, that far from the sun was managing to stay geologically alive. Then there were the mountains. New Horizons revealed towering ranges of what scientists identified as water ice, some standing over 11,000 feet tall, roughly the height of some of the Rockies here on Earth, but made of a material that, at Pluto's extreme temperatures, behaves essentially like solid bedrock rather than the fragile ice we're used to on Earth. Some of these ice mountains appeared to be sitting directly at the edges of that same nitrogen ice plain in Sputnik Planitia, and researchers proposed something that sounded almost like a contradiction. Given the different densities involved, some of these massive water ice mountains may actually be floating, quite literally drifting on top of the denser nitrogen ice underneath them, the same way icebergs float in Earth's oceans, just built from entirely different materials, at temperatures cold enough to freeze nitrogen itself solid. On top of the mountains and the churning ice fields, New Horizons also found strong evidence pointing toward cryovolcanoes, structures that behave like volcanoes in the sense that they appear to have erupted material onto the surface. But instead of molten rock, what they likely erupt is a slushy mixture of water ice and other frozen compounds from beneath Pluto's crust. If confirmed, that would mean Pluto isn't just geologically active on its surface, but has, or at some point had, some kind of internal process capable of pushing material up from underneath a solid icy shell. An idea that carries enormous implications for the biggest question these findings raised. Does Pluto have liquid water hiding beneath all that ice? That question isn't idle speculation. Several independent pieces of evidence gathered by New Horizons point in the same direction. The sheer mass and positioning of Sputnik Planitia itself is one of them. Researchers found that the location and weight of that massive nitrogen ice basin appears to have been enough, over time, to actually cause Pluto to slowly reorient itself, tipping and rotating as a whole body to bring that concentration of mass into a more stable position relative to its spin axis. Modeling that kind of reorientation convincingly generally requires there to be a layer of liquid, or at least slushy, water beneath Pluto's outer ice shell, something dense and mobile enough to allow the crust above it to shift position over geological time. On its own, that's a strong hint. But it's reinforced by what New Horizons found at Pluto's largest moon, Charon, roughly half of Pluto's own diameter, and locked in a mutual, tidally synchronized orbit with it. Charon's surface displays an enormous belt of tectonic fractures and canyons running around its equator, a pattern that planetary scientists strongly associate with the specific, violent process of an internal ocean freezing and expanding long ago, cracking the moon's outer shell as the water beneath it turned to ice and grew in volume. If Charon shows this kind of evidence and Pluto's own surface behavior suggests something similar happening beneath its own crust, the picture that emerges is one where at least two small, distant, icy worlds in the outer solar system may be hiding oceans of liquid water. A possibility that carries genuine weight for scientists interested in where else in our solar system conditions capable of supporting life, even simple life, might exist. Pluto's atmosphere held its own set of surprises. Before the flyby, models predicted that Pluto's thin nitrogen atmosphere, heated by weak but present sunlight, should be losing gas to space fairly rapidly, streaming away in a process similar to how comets lose material as they approach the sun. What New Horizons actually measured was an atmosphere escaping far more slowly than expected, and colder in its upper layers than any existing model had predicted. That unexpectedly cold upper atmosphere turned out to be the key to explaining the slower escape rate, because temperature plays a direct role in how quickly atmospheric particles gain enough energy to break free of a planet's gravity altogether. On top of that, New Horizons captured stunning backlit images of Pluto's atmosphere as the spacecraft looked back at the dwarf planet after its closest approach, revealing dozens of distinct haze layers extending far higher above the surface than anyone anticipated, produced by sunlight triggering chemical reactions among the gases in Pluto's thin atmosphere, gradually building up complex organic particles that then settle back down toward the surface over time, likely contributing to some of the reddish-brown coloring visible across parts of Pluto's terrain. Charon delivered its own share of individually striking discoveries too. Alongside that equatorial tectonic belt hinting at an ancient frozen ocean, New Horizons photographed a distinctive dark reddish region sitting directly over Charon's North Pole, informally nicknamed Mordor by the mission team, a splotch of color scientists believe may be created by gases escaping Pluto's own atmosphere, drifting across space and settling onto Charon's polar region, where extreme cold causes them to freeze out and chemically transform into darker, reddish compounds over time, a genuinely strange example of one small world directly altering the surface chemistry of its neighboring moon through nothing more than slowly leaking gas. Taken together, these findings amounted to one of the most complete overhauls of scientific understanding that any single planetary flyby has ever produced. A year after the encounter, Alan Stern, the mission's principal investigator, summarized it plainly. The complexity of Pluto and its moons turned out to be far beyond anything the team had expected walking in. The degree of ongoing surface activity was simply astounding for a world that far from the sun, and the atmospheric findings alone upended nearly every pre-flyby model that had been built to predict what New Horizons would find. New Horizons didn't stop at Pluto either. After the encounter, the mission was extended, and the spacecraft was redirected toward a small, distant object out in the Kuiper Belt called Arakoth, reaching it on January the 1st, 2019, and becoming the first, and to this day only, spacecraft ever to explore a second Kuiper Belt object up close, revealing a strange two-lobed shape that offered scientists a rare direct look at what may be a genuinely primordial building block left over from the earliest days of the solar system's formation, largely unchanged for over 4 billion years. And the spacecraft has kept going since then, moving steadily outward. In October of 2024, New Horizons passed a distance 60 times farther from the Sun than Earth is, meaning it is now twice as far out as Pluto itself was on the day of that historic 2015 flyby, continuing to send back data as it travels deeper into a region of the solar system that remains almost entirely unexplored by any other spacecraft. And here's the part that keeps this story genuinely alive today, more than a decade after the flyby itself. Scientists are still actively working through the enormous stockpile of data New Horizons gathered during those few hours in July of 2015. New research using that same data set continues to be published years later, refining exactly how Sputnik Planitia formed, exactly how Pluto's reorientation actually played out, and exactly what processes are still shaping the dwarf planet's surface today. A single high-speed flyby, lasting only hours, is still producing new scientific papers, new questions, and new pieces of a still unfinished picture, more than 10 years after the spacecraft that captured it all had already sped past Pluto and continued on into the dark. Before 2015, Pluto was, to most people, little more than a dot on a chart, a name from grade school science class, demoted from full planet status in 2006, the very same year New Horizons launched toward it. What that spacecraft found when it finally arrived turned that dot into an entire world, complete with mountains, glaciers, possible volcanoes, a hazy, layered atmosphere, and quite possibly hidden somewhere beneath miles of ice. An ocean that has been sitting there in darkness for billions of years, waiting for a single small spacecraft, moving too fast to stop, to finally prove it might actually be there. If stories like this, the moments where a single flyby quietly rewrites an entire textbook, are what you come here for, stay close, because there is more still waiting, out past the edge of everything we thought we already knew.